Okay, so far we found some patterns in table of values, as well as patterns in triangles, and use those. In math, we often use patterns to help us find information graphically. So let's graph each line segment, state the coordinates of its midpoint, and that midpoint is that big M. So 2, 3, 2, 3, and 6, 3. So if we needed to determine the midpoint, the middle of this section of that line, we could count 1, 2, 3, 4. It's 4 of them wide, so 2 in the middle. There it is. The midpoint of AB is going to be 4, 3. Let's see, negative 3, negative 1, negative 3, negative 5. So going up and down, the midpoint of that line, 1, 2, 3, 4, oh, half of it right there, so there it is, negative 3, negative 3. Excellent. So horizontal lines, vertical lines, easy to count. Let's add a few more lines. Point E is at 1, 1, and F is at 5, 5. So now we have a line that isn't horizontal or vertical, an increasing line segment, but it's the same thing. If we look at where it starts on the left, where it ends on the right, we can see that that's 1, 2, 3, 4 apart. So we're still going to look at half of that is 2. If we look at how low it starts and how high it ends, that's 1, 2, 3, 4. So halfway between that is 2, which is, oh, right there. So the midpoint of those 2 points of that line segment is 3, 3. So let's see, 4, 7, and negative 2, 9. The same thing, if I look, the midpoint, too high, where the line goes, decreases 2, half of that is 1. So where is the line cross? At 8. If I think left to right, it's 1, 2, 3, 4, 5, 6. Half of that is 3, so 3 from each side. There's my midpoint, 1, 8. Okay. Now, if you did that sort of thing, maybe explain in words, but I'm going to add a few points. We're going to do one more together. So let's say I added 1, negative 9, and the point 9, negative 2. Sure. If I add that line, and I just did it down here so that there's some space to see. If we think about from top to bottom, I'm going to do it dotted. That's where the line ends, where it began, and from left to right, where it begins, where it ends. I'm going to do it dotted again. It forms a shape. And we should be familiar with that shape. And that shape, because it has a horizontal component and a vertical component, has a 90-degree corner. So if we think about that, we might see that, oh, we have a bottom that started at 1, went to 9, that's 8 apart, and halfway is 5. And there's 5. Or if we think about the vertical aspect of that line, it was at negative 2 and went down to 9. That's a change of 7. And half of that is 3.5. So 2 minus another 3.5 is negative 5.5, which is negative 11 halves. which, look at that, there it is. So, based on that kind of thing, or anything that you think, how would we find the midpoint? And write that down. Now, using maybe this last example that I did, what is 5, or the coordinates, 5, and I'm going to use fraction, negative 11 halves. What does that have to do with, what does 5 have to do with 9 and 1? And what does negative 11 halves, or negative 5 and a half, have to do with negative 9 and negative 2? Maybe you can be the mathematician and create the formula. Okay, let's do it together. So we think that 5 is really 1 plus 9 is 10. We split it in half, divide by 2, we get to 5. Oh. Negative 2 minus 9 is negative 11, split it in 2, and we have negative 11 halves, or negative 5 and a half. And that's exactly what we do. So the formula for midpoint, a big capital M, because it's a point, it's going to be in brackets, it's coordinates, which means we have an x and a y. And what it is we're going to have our first x value plus our second x value divide by 2. And we're going to have our first y value plus our second y value divide by 2. So let's see. Using the formula, determine the midpoint of the following pairs of points. So point A and B. So the midpoint of AB is going to be an x aspect and a y aspect divided by 2. And it's going to be added in between. So let's see. So we have x1, x2. So we're going to have 4 plus negative 8. And we're going to have the y aspects, negative 3 plus negative 5. And I can do all those steps all at once, that math, even though there's double signs. 4 take away 8 is negative 4 divided by 2 is negative 2. Negative 3 plus negative 5 is negative 3. Take away 5 is negative 8. Divided by 2 is negative 4. And there's the midpoint for the actual line. So if the line's really far apart, we don't have a graph, we can trust the math that supports our graph. So same thing. The midpoint of CD is going to be negative 3 plus 7 all divided by 2, our x's. Our y's 0 plus negative 5. I could just put 0, take away 5, all divided by 2. And now I math. Negative 3 plus 7 is 4, divided by 2 is 2. 0 plus negative 5 is 0, take away 5. Negative 5 divided by 2 is negative 5 halves. Don't be afraid of fractions. Anything over 2 is actually a decent decimal, so you might write it as 2 and negative 2.5. Cool. All right, flip the page. For a line segment, DE, one endpoint is D, and the midpoint is 4, 2. So let's just draw this for a second. Here's DE, here's the midpoint of DE. So D is 6, 5. The midpoint is 4, 2. Find the coordinates of E. Okay, well let's think about how we would problem solve that. The formula, midpoint is equal to x1 plus x2 all divided by 2, comma y1 plus y2 all divided by 2. So let's see what we got. Well, we have an actual midpoint, 4, 2. And we have an x1 and a y1. So if we look at that, we think about what pairs up with what. Well, our x's pair up with our x aspect. And our y value of our midpoint needs to pair up with that. That's how we would get there. So we essentially end up creating two mini formulas. 4 equals 6 plus x over 2. And then we solve. Let's see, this is all over 2. So let's do this whole thing times 2, which means that times 2. I don't have space, so I'm going to go here. 8 equals 6 plus x. Take away 6, take away 6. X equals 2. So there we have the start of our point. So point E is actually 2 something. We look at what matches up for our y. We have 2 equals 5 plus y all over 2. And then we solve. So now we have the actual other endpoint. Therefore, the endpoint E is the coordinates to -1. Super duper. Okay. Here's a try. Do it again. Let's see. Can you do that? Give it a try. So we have exactly the same thing. One end of the line segment. We need to know the other endpoint. And that equals our midpoint. So from that, for our x-coordinate, for our y-coordinate, and then solve. Super duper. Okay, our last example. For line segment AB, A has the coordinates -6, 4. B is on the x-axis, which means our y value is 0. The midpoint is on the y-axis, which means our x value is 0. So we do exactly what we've just done, and we set it up. So we have a midpoint, 0y, and that's going to equal -6 plus x all over 2, comma 4 plus 0 all over 2. So once again, we match up our x and our x, and we solve. Times 2. And we solve. This is exciting. Logic, isn't it great when it works out? And there's our line. Rough sketch, help me understand. Okay, let's practice using midpoint.